In this lecture, we'll talk about classes a little bit more, just a little bit more. We just want to give enough about classes to express the minimum that we need to understand about classes in order to go ahead and start using library functions using Arduino libraries, because they refer to classes often. So we'll just touch on classes a little bit more, just give a definition, and then we'll move on. Classes. So classes basically, they bring data and functions together and give them a name. Okay. So in this example right here, I define a class called X. You can see it says class X. Oh, pardon my indentation. It's a little so-so. Class X. And there's a curly brackets. Inside class X, you see public. That just means that the data inside there is public. Anybody can see it. We don't need to focus on that. But inside there, inside class X, I define two things, int m and then int mf. Now, m is just a variable, an integer, right? So now what that's saying is that inside this class X, every time I make a new object of that class, it's going to have a variable called m, all to itself. And it's going to be an integer. Now, then the next line, it says int mf. But notice that the mf has parentheses after it, int v inside parentheses after it. Since it has those parentheses, the machine knows, the compiler knows that is a function. So m is a variable, but mf is a function that I'm defining. So I say int mf, it takes an integer v, it returns an integer. And then in curly brackets after that, you can see the three lines of code. Int old equals m, semicolon, m equals v, semicolon, return old, semicolon, right? So inside this class X, I've defined two things. A variable m that's associated with this class X, and every object of the class X, and then a function mf, which is associated with the class X. And so I've defined the class up there. Now then the last three lines up there, I'm actually using the class. So let's take that next line, x var, semicolon. What that does is it just declares a new object of type of class X. Okay? So you know how I would say int? I might say int var, and then it would make var an integer. Well, by saying x var, I'm making var an object of class X. So that means when I make that, I'm implicitly making a variable m, because var, it's a new object of that class, so it's got to have its variable m. So there's going to be some m variable in there that's dedicated to that object, okay, even though I don't explicitly say it. Now then the next line, I say var.m equals 7. So what I'm doing there is I'm taking that m that's associated with var, the new object that I just created, and setting it equal to 7. So note that I don't just say m equals 7, because if I said that, the machine wouldn't know which m I'm talking about. I say var.m equals 7. Okay? So then it knows, okay, the m associated with this var object, that's going to equal 7. And then the next line, I define a new variable z, and I say z equals var.mf, 9, right? So in that case, I'm calling a function. Mf is a function that's associated with that class. So I say var.mf tells me, oh, I want the function associated with this class that var is a part of, that mf function. It calls that function, passes the argument 9 to it, and which returns an integer, and then z is set equal to that integer. So I'm just showing an example where I'm defining the variable, assigning it a value, and then I'm calling a function inside the class as well. So the declaration of the variable creates an object. So when I say x var, it creates an object of that class. And we're calling it var, of that class X. Then a dot operator is very important here. The dot operator is used to access the members. So when you talk about a class and its members, the members are the things that are part of the class. Okay? So for instance, in our class, it has, we can say it has two members, m, which is a variable in there, and mf, which is a function in there. So this class, we can say, has two members. And the way you refer to the members is with this dot operator. So the data and the function, you refer to them with the dot operator, and you see we do that var.m. And what's to the left of the dot tells you this is where you're going to get the m from. You're going to get it from var. Var is m. And then var.mf. Okay, look for var, the class that's part of. That's the mf that we're going to use. So the dot operator is important for referencing these things. Functions can be defined inside the class, so we're doing that here, right? We define variables inside the class, int m, but we can also define functions, int mf, or any number of functions that we want to define. Now, the reason why we're talking about classes at all is because classes are often used in libraries. So when you get a library, an Arduino library, typically they give you a set of classes. And each class contains a bunch of functions that you want to use. And so you have to refer to these functions based by the class name often, or an object name. So so what I'm showing down here is like ethernet.begin. Now, we haven't gotten to this yet, but there's an Ethernet library that you can get from Arduino that you can use with an Ethernet shield. And this library, it has a begin function. When you want to initialize the Ethernet adapter, you have to call this begin function, called begin right there. And you can't just call begin, you have to say ethernet.begin, because it's from this Ethernet class, so it comes with the library. Next, I have serial.begin. So, by the way, begin is an extremely common name for the first function in these libraries, right? The first thing you do to set up the library, you often call begin. So, there's another library called the serial library, if I want to use a serial interface, which we will cover. And that also has a begin. So I can't just say begin, I have to say serial.begin to say I want the begin from the serial class, serial library. Now notice that Ethernet library and serial library both have begin functions associated with them. And in order for the machine, the compiler, to know which one I'm referring to, I have to prefix it with the name of the library or the name of the class. So ethernet.begin, serial.begin. We get the same thing with the print. You can have a serial.print, we'll cover that, where it prints something on the serial cable. But then client.print, client is the name of an object that you can create inside the Ethernet library. You have to say, and that does something completely different. Client.print actually takes that word hello and sends it as a message, okay, on the internet. So those two prints do completely different things, and you have to prefix the print with the name of the object and the name of the class where the function comes from. So this is why we're actually learning about classes at all, is so that you understand what you're doing when you make these calls to library functions, these Arduino libraries. So we don't need to know a lot about classes. We will not define classes in this course. We'll just use predefined classes that come with the library. So we'll use the classes that are defined in these libraries, like Ethernet or Serial or whatever the libraries are. And we'll hit these as we go through the lectures. We'll talk more about different libraries and the classes that they define. Thank you.